Okay, I want to talk about parabolas here in this unit. Parabolas are a very important conic figure that have a lot of real-life examples. Provided a video that involves all the different things as far as satellite dishes and all the different real-life examples. Later on, you're going to see a real-life example of me shooting a basketball, which is very entertaining. And parabolas have a lot of features that we really use every single day. So there's a PowerPoint that goes through some equations that you're going to need, and there's a couple of videos that you want to take a look at, but here's our lessons on parabolas. Okay, I'm going to show you a few parabola examples today. These equations are what we call in vertex form of the parabola. We'll do them when they're in standard form. We have to generate the vertex form out. But the first thing I'm going to recognize is this equation is a parabola. I have to identify that between parabola, ellipses, hyperbolas. This is a parabola because we have the x term being squared, but the y term is going to be to the first power. So that's going to make this a parabola. The next thing that I'm going to notice with these parabolas is anytime the x term is squared, the parabola is going to have a vertical axis of symmetry. It's either going to be concave upward or concave downward. Okay? I'm then going to look at this number, and since this number is a positive value, that means this parabola is going to be concave upward. If that were negative, it would be concave downward. Okay? So I'm going to identify the vertex of the parabola. Looking back through the PowerPoint presentation, find the equation, and the vertex of this parabola is going to be positive 4, positive 3. So I put that over here, 4, 3, as my vertex. And make sure you put these equations correctly. I've seen people put 4, negative 3 up here, you know what I mean? So you got to make sure you do the coordinates correctly. So this parabola is now going to be concaved upward. So if I make a rough graph of this, it's going to look something like that. And that's a very rough graph, isn't it? I can get very more refined in this by finding where this would cross the y-axis. If I simply put in 0 for x and I solve that equation, that would tell me where that crosses the y-axis. But I'm going to identify two other major things with the parabola. Again, referring back to your PowerPoint, one of the major things is something called the focus of the parabola. The focus of the parabola is a point that's always inside of the parabola that lies on the axis of symmetry. To find where that point is, I have to find the value of p. And to find the value of p, I'm always going to take this number divided by 4. So in this case, my value of p is 4. What that means is I'm going to move 4 units from the vertex inside of the parabola to locate my focus. So if the vertex is 4 over 3 up, the focus is going to be 4 over 7 up. Okay? Again, if that p value would have been a negative number, it would have moved the focus below the vertex, and it would make the parabola concave downward. Okay? And the last thing that I'm going to identify is a line called the directrix. The directrix is a line segment that's also p units from the vertex, but it's always outside of the parabola. And so I'm going to move 4 units on the outside, which is going to take me down to y equals negative 1. And again, the directrix is a line outside of the parabola. It's always perpendicular to the axis of symmetry. And again, the axis of symmetry, referring back to the PowerPoint, would be a line that cuts this parabola in half. And so the directrix, focus, and vertex are all major components of your parabola. Our next example with parabolas is going to be a parabola where the axis of symmetry is going to be horizontal. And that is going to be a parabola that has the form with the y squared. Again, the y squared is going to perform a parabola that looks this way, or it's going to go this way. So we're going to have to determine that. The first thing I'm going to always do, though, is I'm going to locate the vertex of the parabola. So the vertex of the parabola, again, you're going to have to refer back to the PowerPoint, which has the general form of the equation. The vertex is going to be at the point HK, but now my parabola variables are switched around. So now the H term goes with the X. There's no H term there, is there? So what is it when there's nothing there? It ain't nothing. It's 0. The H term is going to be 0. So the H term is 0. The K term is -6. Again, the general form has y minus 6. So it's going to be -6. Okay? So if you didn't quite get that, let me rewind and show you. And it's 0. Ha! Just kidding you. You guys are all checking your VCRs, trying to figure out what you did wrong. There's nothing. It's just me playing. Okay, back to this problem. So now let me plot the vertex of this parabola. 0, -6 is going to be right here. Okay, that's going to be the vertex. Now, the next thing I'm going to do is I'm going to try to figure out which way the parabola goes. Again, axis of symmetry is going to be horizontal, making the parabola go this way or this way. So since the P term is now negative, the parabola is going to be this direction. Again, that is a very rough draft of that parabola, and we could, again, make it much more precise by finding places where it may cross the axis. If I want to find out where it crosses the x-axis, simply put in 0 for y in my equation and solve for x. So that's the general form of what that parabola is going to look like. Again, I'd like to place the focus in the directrix. The focus is a point, p units from the vertex inside of the parabola. So the parabola being concave this way, I'm going to have to move -3, or 3 units to the left. I always take this term, divide by 4, to find my p-value. Again, this all refers back to the general form that you're going to find in your PowerPoint. So the p-value here is going to be 3. The focus is going to move 3 units to the left. So if this point is 0, -6, the focus is going to be right here inside the parabola at the point -3, -6. The directrix is a line outside the parabola. It is also 3 units from the vertex. And it's going to always be perpendicular to the axis of symmetry. The axis of symmetry is that line. It's going to cut that parabola in half. So the directrix is going to go 3 units outside the parabola, and it's going to be a line right here, and that line is going to be x equals 3, and that is going to be your directrix. So we have to be able to identify the vertex, the focus, and the directrix. Okay, this is going to be a parabola in real life as I take and I make a shot. I can't believe I missed. I'm going to have to go back and rewrite my equation of that parabola to figure this out. Okay, got it. Let's see. If I change this vertex of this parabola and I change where the focus is going to be, I change the focus here, bring it down, take this over here, that should change my focus to negative, and that should give me the direct. Okay, let's try that. Let's go. Okay, we reworked the equation of the parabola. We think it's going to work, but we also need to get a little physical work in here, so we're a little bit better with our legs. So we're going to do a little jump roping. And okay, let's go see. Okay, we're back here now live So, also with parabolas, there's a couple things that we should be able to do. One is work backwards. If we're given things like the focus, the vertex, the directrix, we should be able to work backwards and find the equation in vertex form. So if I look at this parabola here, I have the focus given to me as the point 4,3, and I have the directrix, or excuse me, the vertex, given me as 0.40. So I should be able to write the equation of this working backwards. So if we look at the general form of the equation of a parabola in this form, it's going to be like that right there, okay? So the first thing I'm going to do is I'm going to replace the h and the k with the 4 and the 0. So that's going to give me x minus 4 quantity squared equals, and over here it's just going to be y minus 0, which I can just leave that as y. So basically all I need to do to finish this parabola off is I need to figure out what this p-value is. Now working backwards, when we had the equation before and we were trying to figure out the p-value, we always divided by 4. So now what we're going to do is we're going to take and figure out how far this p-value is by figuring out how far the focus is from the vertex. The focus is 3 units from the vertex. So that means my p-value is 3. Once I have the p-value, I'm going to multiply by 4 to figure out this number here. 4 times 3 is 12. And so there's the equation of that parabola given the focus and the vertex. So anytime you know focus, vertex, you could be given maybe focus directrix, which would allow you to find the vertex because it's in the middle. And if you get 2 out of 3 of those things, as we all know, that's meatloaf. 2 out of 3 ain't bad, right? We should be able to figure out the equation of the parabola. Does this fit what we know? The x term is squared, the parabola has a concaved upward. Okay? The p-value is positive, which makes the parabola go upward also. All right, next thing we want to be able to do is take a parabola that's not in vertex form and rewrite it in vertex form so we can graph it and find the vertex, the focus, and the directrix. So as you notice right now, when I look at this equation, I'm going to have to identify, is this a parabola, an ellipse, or hyperbola? Well, I know it's a parabola because the y term is being squared, but the x term is not being squared. So I know it's a parabola. I also know the axis of symmetry is going to be a horizontal line. The parabola is going to be this way, or it's going to be this way. So I know a lot of things by just looking at the equation. To do this task of converting this to vertex form, I'm going to have to complete the square on the term that is being squared. So what I'm going to do to begin with is I'm going to take the y squared terms, or any term that has a y in it, and put on one side. And any term that does not have a y in it, I'm going to take to the other side of the equation. Okay, now I'm going to complete the square. So completing the square, we know the coefficient of the y squared term has to be 1. It's already good to go. So to complete the square, we take 1/2 of the coefficient of the y term, which is 3, and we square it. 3 squared is 9. That means I'm going to put a 9 there, but we also know that we can't just add 9 to one side of an equation. Whatever we do to one side, we have to do the same thing to the other side. So I'm going to put a 9 over here. Okay, now what that leaves me over here on this left side is a perfect square trinomial, a PST, if you will. Y plus 3 quantity squared. And that is what I was trying to do. That's what puts that in vertex form. Okay, over here I'm going to have to do some arithmetic. Negative 25 plus 9 is negative 16. Well, it's starting to look very much like it's in vertex form, with one exception over here. I'm going to have to factor out a negative 8. And now I have that equation that looks just like our vertex form. We can tell this parabola is going to have an axis of symmetry, it's horizontal, and it's going to be shaped like this, okay? And the vertex is going to be -2, -3. And then find the focus and directrix will be the same as we did in previous lessons. Boom!